Okay, so like I said yesterday, we are just going to be moving on to doing ionic naming that is called ternary ionic naming. And all that means is there's going to be a polyatomic ion. So you're going to have to go back up and look at the first page of your notes right here that has your polyatomic ion list, because you're going to have those in all these problems. Now, how you recognize the difference, how do I know when I'm going to have a polyatomic ion, is there's going to be more than two elements. So yesterday's naming, you'll notice one element, two element, one element, two element, one element, two element. They all had two elements. So those are the only three rules I needed to do. It's a metal with a nonmetal. It's only a metal with one nonmetal, so just two elements. Then that's the naming rules I follow. Today, it's still ionic. It's still a metal with a nonmetal, or it's still a positive with a negative charge. But this time, 1, 2, 3 elements. 1, 2, 3 elements. Usually 3, there could be more, but at least 3 elements or more. That's how you know the difference between these ones compared to yesterday's. All right, so let's do this. Move me out of the way over here. All right, so the first rule is still the same. Same as yesterday, name the first element as usual, except for, I really should have added this in, if the metal is not in the first two columns of the periodic table, then it needs the Roman numerals. So that's still true. So basically it's the same rules as yesterday, the first two rules. It's still going to need that Roman numeral if it's in the middle section. Okay, so that's still true from yesterday, but all we're changing is now there's going to be a polyatomic ion somewhere in this formula, either usually at the end, almost always it's the ending, but there is one case where the polyatomic ion comes first. Now, in the polyatomic ion, we do not change it to I, no changing, because that's what that polyatomic ion is called. We can't change it. Do not change the ending. You literally just write it the way it looked on your polyatomic ion list on your first page of notes. All right, let's begin. So I'm going to find Ca on the periodic table. Ca on the periodic table is calcium. Okay, so calcium is in those first two columns. So if I'm looking at my mock periodic table, it's in this second column here. So if it's in that column, I don't need Roman numerals. I'm done with that part. Now I know there's more than two elements, so this, and calcium is my polyatomic, so SO4 is my polyatomic. So I'm going to go look up this polyatomic ion and see what it's called and write it down. It's SO4. So let's go look. Is it not going to let me drag it up? Weird. So I'll have to do it over here. And then on the rest of them, you're just going to have to believe me that I found it on the list. But I want to show you at least once. So SO4 on the list is right here. SO4 is called sulfate. So that's what I'm going to write down is sulfate, because that's what SO4 is. So going back down right here. Okay. So I'm going to write down sulfate. That's it. I'm done. I don't change polyatomic names. It is sulfate, so I write sulfate. I didn't need Roman numerals in the middle because calcium is in the first two columns. So done. That's it. All right, next one. Iron. Fe. I look at Fe on the periodic table. It's around here, so I don't know its charge. It isn't in the first two columns. I'm going to need Roman numerals. But I'll start by writing its name, not changing it. It's called iron. But I know I'm going to need Roman numerals, so I'm going to go ahead and put those in the middle in parentheses. Now this helped me out. I know that NO3 is my polyatomic because they grouped it in parentheses for me. So NO3, I'm going to look at my polyatomic ion list. You could scroll up and look for it too, because it's going to be messed up every time I scroll up. So I'm just going to, you're going to have to believe me. I'm looking at my list right now. Nitrate, well, that's what it's called. NO3 is nitrate. So that's what I'm going to write down. NO3 is called nitrate. Now, remember yesterday, we had to figure out the charge. I don't know iron's charge. That's the point of this. I don't know what it is, so I'm going to have to find it. Nitrate is a -1 charge, but there's 3 of them. So I have 1, -1, 2, -1. Where did I write the 3? Because I was thinking 3 in my head. 3 -1s, all right? So I have each of those nitrates, 3 of them, has a -1 charge. So that total, I have a total of a -3 going on in this compound, and I need it to balance to 0. So obviously my iron is going to have to be a +3, and there's only 1 iron. So that 1 iron has to be that total +3, or this compound will not balance. So this iron is a 3 charge. And there you go. Again, you don't have to draw the bars on top and bottom. You could have just done 3 I's if you were typing this in the in the computer. It could have been capital I, capital I, capital I, all next to each other. All right, next one. Now I'm looking at this one. It does have 3 elements, but when you look for H4Cl, you think that's your polyatomic because usually polyatomics are last. You're not going to find H4Cl. That's not a polyatomic ion. So this is that one weird exception to the rule where the polyatomic ion is actually written first. It's almost never not. It's almost always a metal, then a polyatomic ion. But this is a positive polyatomic. And remember, metals are positive. So it's positive things are always written first. So this one is my polyatomic that I have to go look up. I'm going to go look up NH4 on my polyatomic ion list. You're just going to have to start recognizing it. When you see NH4, it's a polyatomic ion. You got to go look it up. It's the only positive one. It's in group it's in group 5, and it's called ammonium. So this polyatomic is called ammonium. Done. I don't change its name. I don't do anything to it. NH4 is ammonium. And then I have this non-metal at the end, which followed that rule from previously that if it's a non-metal, leave off the N and non-metal, then its ending is still I. So that's still true. It's just usually that doesn't happen because usually the endings are polyatomic ions. But in this case, the ending is a non-metal, so we do change it to I. So I find Cl in the periodic table, it's chlorine. So that chlorine becomes chloride. And now we're done. I named the polyatomic, I changed the non-metal to an I, finished. The last one, I look at Cu on the periodic table. Cu on the periodic table is copper. Copper is in this middle section, so I don't know its charge. I'm going to have Roman numerals. I notice that this is more than 2 elements, so this is PO4. That's a polyatomic ion. I'm going to have to go find it. PO4, looking, is in group 5 as well, and it's called phosphate. That is what it's called. So you don't have to memorize these polyatomic ions, what they're called, but you do have to remember when it's more than 2 elements, you gotta go look up its name. It's just phosphate. That's what it's called. I looked it up, wrote it down, phosphate. Now phosphate's charge, so I have to figure out this guy's charge, and I don't know coppers, but I do know phosphates, it's on my list. Phosphate's charge is a -3, but there's 2 of them. So I have 2 -3s. Each of those phosphates, both of them have a -3 charge. So this total compound's charge is a -6, and I need it to balance to 0. Now copper has 3 of them. There are 3 coppers. And those 3 coppers charges have to balance to a +6. So it's +6 minus 6 equals 0. So I need 3 numbers that are all the same that add up to a +6, which would be a +2, +2, +2, 2, 4, 6. So if each of my coppers had a 2 charge, if each of those coppers had a 2 charge, then that would give me a balanced compound. +2, +2, +2, which is a +6, -3, -3, which is a -6. And there we go. That's adding on the polyatomic. It's adding on the polyatomic ion bit of ionic naming. And there we go.